All right, this is I-10, write and solve equations for proportional relationships. All right, the story says, in a flash of sheer brilliance, Leon invents a time machine. The machine uses a small nuclear reactor to generate electricity it needs to travel back in time. There is a proportional relationship between how many years that Leon wants to travel back in time, x, and how much electricity in megawatts his time machine needs in y, or his time machine needs, and that's our y. So I'm gonna pick out a couple pieces of information in the story. So how many years is x? Okay, so x equals years, and our y is electricity is our y. How much electricity his time machine needs is a y. All right, so we're going to write an equation for this, but we're told that to travel back 7 years, okay, to travel 7 years, Leon's time machine needs 14 megawatts of electricity. Write an equation for this relationship. Okay, so here our equation is going to start with y equals, and since it's a proportional relationship, we can say kx. Okay, so we got to fill in that number k. So y equals a number x. All right, this is like I3 or something. So if we remember that number, let's see, I'm going to need a little bit more space. I'm going to move that down. So that number that goes in there is our k value, and k equals y over x. So let's find what that equals. Y over x. And remember, y is our electricity. So here we got y is 14 megawatts. Let's put 14. And then our x is our years, right? We labeled that all here on the left side, both of those. So x is 7 years. So 14 over 7 equals 2. So our equation that I'm going to write in there is y equals 2x. So let's type that in, 2x. We got 2 because 14 divided by 2, 14 years, or 14 megawatts because it's our electricity over 7 years. All right, please rewatch that because that took a lot of time to explain those steps, okay? Let's go to our second part of this problem, which now says, this model is y equals 2x. Yeah, that's what we wrote. So now the second part of this problem. How much electricity would Leon's time machine need to travel back 9 years? And we know that years is our x, okay? So our equation, again, was y equals 2x. And we got 9 years. So x, which is our years, because I circled that in the story, equals 9. So we're going to substitute 9 into the equation. Y equals 2 times 9. All right, so 9 is our x. And 2 times 9 equals 18. So that's what I'm going to write there. Y equals 18. And again, we can double check that I've kept my two variables apart. Y is how many megawatts. See, I'm underlining it there in the story. Y is our megawatts. And now we have 18 megawatts. Right. The third part of this problem now, and yeah, it is all the same problem, but we're still getting points for each part of this problem, okay? So now we have how far can it travel using 20 megawatts? And remember that y here is how much electricity in megawatts. So our equation is y equals 2x. And now we have megawatts is 20. right? That's what we have in the store, in the problem right here. How much will it, how far back can it go if it travels 20 megawatts? So we're going to take the 20 and substitute that into our y, because y equals 20. So 20 equals 2 times the number, right? So this is just solving a one-step equation here. So if you want, you can divide both sides by 2, so that 2's on the right side cancels out, and 20 divided by 2 is 10. 10 equals, and we have x on the left side. And x is how many years? So we have 10 years. Now let's check that in the story problem. How much time is our x? So x is 10, so it's 10 years. All right, and all that work for one problem because we are writing and we are solving these equations. All right. I guess that with that one example, please rewatch each part. There's 3 parts on working through this problem, okay? Please rewatch this video. There is a lot involved in here, right? Good luck. Stay with your assignment. And after this, have yourself a good winter break.